In the last session, we have uncovered some of the core messaging systems concepts, and in this session, we will dig deeper into one of the core concept called message channel and try to explore what types of channels are available and what is the decision criteria to create these channels and who is responsible for creating these channels. Is it the application team or the owner of the messaging systems or the messaging systems team? The first theme for creating these channels is the number of channels or the fixed set of channels. Basically, when two applications decide to exchange data from one application to another, it will be using a channel. And when we install a messaging system onto the environment or the enterprise where we have to integrate the applications, the channels will not be readily available. So it's on to the developers who will be integrating the applications, what sort of data they are trying to share between those applications, what is the data type of those data, and they have to know how many channels might be necessary. So these are all things which should be decided at the design time, not at the runtime. Sure, there will be some message channels that will be or that can be created at the runtime dynamically, but most of the channels that might be necessary for the applications to exchange data should be decided at the design time and agree upon a format, what sort of message data they will be sending across that channel. So there will be a fixed set of channels which should be created at the design time, and the application teams have to make use of those channels when developing these integrations in an enterprise. The next uh, theme or the challenge is determining the set of channels which might be necessary for integrating the applications, uh, whether it should be decided by the messaging systems teams or the app teams. Basically, when we start a fresh integration, uh, in the most cases, it will be the application team who will be deciding how many channels might be necessary and what kind of data types those channels would be carrying. And these details should be shared with the messaging systems team for them to create these channels for them. And the initial set of applications, once they are integrated, then when there is a new application which is willing to participate in that integration, then we have to do an analysis if that application will share the functionality with other applications which are already present in that integration solution. Then it might be necessarily use the existing message channels, and if there is any new functionality which is added into that integration, then certainly there might be new channels that might be needed, which will be shared with the messaging systems again. And this kind of iterative approach is followed until the enterprise integration is completed and seamless. And the next theme we should focus on is the direction of these channels. Basically, the channels are uh, not unidirectional or bidirectional, and they do not have any direction. We can just think about a channel as a bucket where some app will put the data in and some application will take the data out of that bucket. So there is no direction. Only it's when one application sends a data and other application receives the data, then the direction comes into picture. And usually or technically, the channel can be bidirectional, meaning that the application send data to that channel and the same application can consume the data from the same channel. But in reality, uh, it's technically possible, but in reality, if the application sends the data to that channel and also consumes the data from that channel, then there is a chance that the application consumes its own data instead of consuming the data which is sent on that channel by different application. For all good reasons, these channels are kept unidirectional, meaning that one application can send the data but not consume from the same channel, and the other application can receive the data, but again, that cannot send the data on that channel. So it's unidirectional, and the consequence is if those two applications would like to participate in a conversation, then there might be an additional channel that is necessary for the receiver to send back some kind of acknowledgement to the uh, sending application. So this is the downside, but this downside is for all good reasons, not to mess up the entire integration layer. And the next uh, topic I would like to discuss is the channel decisions. So, how do we decide which kind of channel to use? For example, should we use one-to-one channel or one-to-many channel? When I say one-to-one channel, it's a point-to-point channel, which is essentially a JMS queue. And if we choose one-to-many, then it's publish subscribe channel, which is essentially a JMS topic. And there are also certain channels which are readily available in the messaging systems when we install these messaging systems right out of the box, like invalid message or dead letter channel. We will come to this in a while. Let's go back to one-to-one. So imagine a situation where your enterprise handles incoming orders for some shopping related application. So you will be receiving orders on a channel and you have to process those orders. So this is the business case scenario, and obviously you wanted to process one order only once. So in this case, it's appropriate to go for a one-to-one or a point-to-point channel, which will consume the incoming orders like here, order one, order two, order three on this channel, and the receiver will receive these orders in the same sequence, order one, order two, order three, unless we have some parallel processing or multiple receivers to process or multiple receivers to handle the incoming volume, it will be processed in sequence. And this will essentially make sure that one order is only processed once. Now, let's compare it with the one-to-many or publish-subscribe channel. For example, in the same enterprise, there is a business use case where you have a customer in your database, or you maintain a customer related data, and the customer wish to update his address. His address will be essentially in different applications, be it billing or be it invoice or tax related stuff or be it customer care. So there are three different applications which will be having the customer address. And the customer will not send an address change request or a message three times, or say, for example, you have 10 systems which will be having his address. He will not send the address update 10 times. He will only say that, hey, I have an address change, so I'm sending this change request. So he will send one message, which is address change. And in this scenario, you can opt for publish subscribe channel, where you will publish one address change, and on the publish subscribe channel, you have multiple receivers for the same message. And this address change will go a copy of each message, a copy of that message, each message coming on the publish subscribe channel will be sent over to each receiver so that all the systems that are present will have the updated address. So based on the business use case, we can go for a publish subscribe channel or a point-to-point channel. And all this is depending upon the app teams, or it's all app teams' responsibility when designing what kind of channel to pick for certain functionality. We will dig more deeper into the other types. Okay, I forgot to cover an invalid message or a dead letter channel. For example, in ideal case, when we create a channel, um, the expectation is that the sender will only send a valid message on that channel. But in real-time situations, there will be cases where sender might send some invalid data message or invalid or maybe not all mandatory fields are present in that message. So it's quite possible that sender will be sending some invalid messages, but the receiver will have some expectation on that particular message, that the receiver only processes uh, validated messages and on or rejects all the invalid data messages. So where those messages should be delivered. So most of the messaging systems will have by default some of the channels which are for these reasons. Invalid message channel, which hold all the invalid messages on that channel, and hoping that some other monitoring application or some tool will be taking care of those invalid messages on a timely in a timely fashion. And the next one is a dead letter queue. Sometimes not only invalid, but also some weird messages which are not even uh, in line with the receiver's expectations will also be ending up on the channels. So those kind of messages will go to the dead letter channels. So these are some inbuilt or right out of the box channels which are available from different messaging system. The last topic I would like to cover is crash proof or guaranteed delivery. In general, message channel uh, will only have the messages in its memory. So when any crash or any shutdown for any maintenance of the messaging system happens, then when the messaging system is back online, the channel will not hold the messages which were previously present. And if your application or based on the business criticality, if you think that we need to get back all those messages which were present before the downtime or crash, then you have to opt for guaranteed delivery, which is a mechanism where the messaging system persists all the messages to a disk, physical disk, before it is delivered to the receiver and receiver acknowledge that that message is received. And if the receiver is not responding, or for any network failures, or for any crash reasons, or any downtime, then the messages are stored on the disk. And when the systems are back online, those messages from the disk will be put on the channel again for the processing. So this is definitely a performance overhead on all the systems, but you have to see the trade-offs. You have to compare if the performance degradation is uh, okay and message loss is not okay, then you have to go for a guaranteed delivery uh, option. With this, I'll stop here and continue.